Hello, today I'm going to discuss about differentiation. This is the second video. The first video we did, it was about the first principle, definition of the derivative, and how we can find the derivative of a function, differentiation of a function, using first principle. That means using the definition of the function and the definition of the derivative. Now, I am going to give you the rules and how you can do this derivative without using first principle or the definition. So it will be easy for you to calculate the derivative of function, and then after we are going to the application of the derivative. Okay, let us start. Okay, now let us see what are the formulas for derivative of the function. In last class, we differentiated if y is equal to f of x. We said y dash of x, y dash or f dash of x, that means derivative of the function, is equal to limit x, delta x goes to 0, f of x plus delta x minus f of x divided by delta x. And we denote this by dy by dx. By dy by dx. Okay, that is change in y in the numerator. Therefore, this one is change in y divided by change in x. So you are going to get dy by the difference in y divided by difference in x. You are going to get dy by dx. Now, we have done a question like that, which f of x was equal to x squared. If you remember, we said y equal to x squared plus x, and we found the derivative of that, dy by dx. We found the dy by dx, and it was 2x plus 1. We used this definition here to do that. Now, we are going to give rules so that we don't need to do all the limit and everything, and it will be so long to do the calculation. Okay, now first rule, therefore first rule, if y is equal to x to power of n dy by dx is equal to n x to power of n minus 1. So, for example, if you have y equal to x to power of 5, dy by dx is equal to 5 x to power of 4. So, for example, another one, if y is equal to x to power of 2, which we have done it here, we got 2x, therefore you are going to get dy by dx is equal to 2, that means n comes as a coefficient, x to power of 2 minus 1 is 1, therefore is 2x. So, this is the first rule, therefore let me underline it so that you will remember this is our first rule. Now, second rule, if there is a constant multiple of any function you are having, the constant will remain there. That means if you have y equal to k times of f of x, dy by dx will be equal to k times of f dash of x. That means the constant term will remain there, no change at all, if it has a coefficient. For example, if you have y equal to 2 times of x to power of 3, then dy by dx, 3 should be multiplied here, therefore you are going to get 6 x to power of 2. Why 2? Because 3 minus 1 is 2. Why 6? Because 3 times this 2 is 6. Okay, if you have, suppose, y equal to 3 x to power of 7, dy by dx will be 7 times 3, 7 times 3, which is 21, and then x to power of 6. Okay, so we got our second rule also. Now, what is the third rule? Third rule, it says that if y is equal to f of x plus or minus g of x, therefore you are adding or subtracting two functions, then the derivative of that, dy by dx is equal to derivative of this, that means f dash of x. You understand, f dash means df by dx. You can write df by dx also. Plus or minus g dash of x. That means dg by dx. Therefore, you need to differentiate one by one. Therefore, third rule, it says that, example here, it says that, using the third rule, if I have y equal to, suppose, x to power of 3 plus 5x squared, dy by dx is 3x squared plus 2 times 5 is 10 to power of x. Now, it is very clear if you have a constant function. Suppose this is a constant function here. Y equal to c. How much is the slope or gradient of this function? Clearly 0, because it doesn't increase. Y doesn't increase. Change of y is 0, or y is always equal to c. Therefore, there is no change of y. Therefore, this dy, difference in y, is 0. Therefore, this derivative will be 0. So, if you have another example, suppose y is equal to x squared plus 5x minus 3, dy by dx will be equal to, this will be 2x plus, this will be 5, because the power of this is 1 actually. If you subtract 1 will be 0, 5x to power of 0 is 1, therefore this is only 5, and minus 3 will be 0, therefore minus 0, which we don't need to write. Therefore, the derivative of the constant numbers are 0. Constant functions are 0. So, by now, we can differentiate a lot of different functions. Now, let us look at what we have learned till now and give some examples of that. The first thing I want to discuss about it, this n here, which we are having in the first thing, this n can be any number. Now I have given all integers, natural numbers even. All my examples are natural numbers. Not necessary, it is not necessary to be a natural number. That means power can be anything. The rule withhold. I will give one example for that. If suppose you have y equal to 1 over x squared plus a square root of x. Now you want to find dy by dx. First, you write y as an exponential format. That is, x squared in the denominator means x is negative, therefore x to power of negative 2. And this is a fraction power. That is second root, therefore x to power of 1 over 2. Now you can apply the rule. Therefore, now dy by dx is equal to, this power comes as a coefficient, therefore negative 2, x to power of negative 2 minus 1. You are subtracting as usual. The next one, half, n is half, comes down, x to power of negative half. Therefore, the answer will be, if you want to simplify it, minus 2, x to power of negative 3, plus 1 over 2, x to power of negative half. Now, if you don't like this format, by any reason, now it is done, differentiation is done, but you can write this one as a negative 2 divided by x to the power of 3, because it comes to denominator, therefore the power changes to positive. And this we can write 1 over 2 to the power of 2 times x to the power of half. X to the power of half is what? X to the power of half is the square root of x. Therefore you can write this in the format of 2 divided by x to the power of 3 plus 1 2 times of square root of x. You see, this here and here are exactly same thing, only you are changing the format. Therefore, this is one kind of writing a square root of root. This is one kind of writing a square root of 2, and this is another kind of writing a square root of 2. Therefore, these are exactly same thing. Now, let us do one more example like that. Suppose y is equal to 3 divided by x plus 1 divided by third root of x squared. Okay, now I want to differentiate this one. First, I will write this in the exponential format. What is that? This is y, this is 3, this x is to the power of 1, but it is in the denominator. That means x is to the power of negative 1. Plus, here the power is 2 divided by 3. 2 divided by 3, this is the power. But this is in the denominator, therefore it will be x to the power of negative 2 over 3. That is third root of x squared. Third root of x squared. So now this in this format, I can apply my rule, dy by dx. This 3 is constant, you are writing this negative 1 comes down, n. X to the power of negative 1, negative 1, minus 1, subtract 1. And here negative 2 over 3 comes down, x to the power of negative 2 over 3 minus 1. Now we can simplify this. This is negative 2, therefore the answer is negative 3 divided by x squared. Because it is negative power, it goes to denominator. This is a minus, now this 2 is there, this 3 is in denominator. This power is actually how much? If you add these two numbers, you are going to get negative 5 over 3. Therefore, because it's negative 5 over 3, x, it should go in the denominator, 5 over 3. Therefore, this is like that. Therefore, this you can write minus 3, x to the power of 2, minus 2 times of 3, third root of x to the power of 5. X to the power of 5 means x to the power of 3 times x to the power of 2. You can take it out if you like. Therefore, x to the power of 3 can come out, be x here, and third root of x squared. Okay, all these steps you have done here, it is not necessary. All of them are equivalent. You can just write it like that. Even this one, if you simplify it, then it is all of them are exactly same thing. Therefore, in different format you are writing. That is depend how much you want to simplify your answer. Nothing to do with calculus. Nothing to do with the sorry. Here x to the power of 2 also. So, you understood the rules. Till now, we have given actually 3 different rules here. Till now, you can use these 3 rules to differentiate a lot of different functions. Now, there are more rules. I'm going to give 2 more rules so that you can do the multiplication and also division. But after that, I will go to application and derivative of the other functions which are polynomials. Now we can do the polynomials and then algebraic function, trigonometric function, and log function. We will do another session. Now let's go for differentiation of the multiplication. Now let's see how is that. If your function y is equal to u times v, where u and v are functions of x. That means, for example, this is x squared, this is, I don't know, something square root of x or whatever is that. You can differentiate it like that. dy by dx is equal to du by dx times v plus dv by dx times u. That means you differentiate this, the first one, multiply by the second one, and differentiate the second one, then multiply by first one. Okay? Now, let us give an example. Suppose you have y equal to x squared plus 2x, and then times x to the power of 3 minus 5. Now, you may tell me you can just multiply this and differentiate. Yeah, you can do that. But if there are some of the function which is you are not able to multiply them, we can see later on, then you have a problem. So let us practice this, and then we can see what will happen later. Now, if I want to differentiate this, I have to write dy by dx. Find the derivative of this. Don't look at this, just find the derivative of the first one. Therefore, this is 2x and this is 2 because the power is 1. 1 times 2 will be 2, then power will be 0. X to the power of 0 is equal to 1. Now, multiply by it the second one. Therefore, second one you are writing itself. You can see that this is if I write this by u dash, or simply this is u dash, this is v, and then plus. Now this time you differentiate this one. This will be 3x squared, and the 5 will be 0. Therefore, this is 3x squared times, now this one, x squared plus 2x. Therefore, this is v dash times u. That is derivative of this function. Now, I'm not going to simplify this because we are just learning the rules, so that not necessary to simplify the function. Otherwise, you can multiply this and then find the final answer. Now, anyhow, let me continue with another example. Suppose I have y equal to x3 minus 2x plus 1 times x squared plus 5x minus 7. If I want to find the derivative of this function, dy by dx, it says that first differentiate this one, which is 3x squared minus 2. Then just copy the next one, x squared plus 5x minus 7. Then plus differentiate the second one, 2x second one, differentiate this one. Okay, then when I differentiate that one, then I'm going to get 2x plus 5 times the first one, x cubed minus 2x plus 1. Now this is derivative of that function. Now, this was actually our fourth rule, which I wrote it here. so that I will put it in the red box. You will remember that this is our fourth rule. Now let's try to do the last rule here, and that is if you are having quotient. Rule 5, if y is equal to u divided by v, again u and v are functions of x, then dy by dx is equal to du by dx therefore this is derivative of this du by dx times v, but here is negative. Now differentiate v, dv by dx times u, then divided by v squared, divided by v squared. For example, I have y equal to 2x plus 1 divided by x minus 1. I want to find dy by dx. dy by dx is equal to first differentiate numerator here. Differentiate this one. Okay? What is the derivative of this? 2x plus 1. Derivative of 2x is 2 and 1 is 0. Therefore, this is 2 only. 2 times denominator times this. Therefore, this will be x minus 1. Now, minus, now this time you differentiate this one. Differentiate this one. Derivative of x is 1. Derivative of 1 is 0. Therefore, this is 1. Therefore 1 times 2x plus 1, which is the numerator. Then divided by denominator to power of 2. Therefore x minus 1 to power of 2. So this is easily can be simplified. You are getting 2x here, minus 2x it cancels, and then you are getting negative 3. If you want to simplify this one, you are getting negative 3 divided by x minus 1 squared. So that this is derivative of this function. Okay, this is enough for today. We will continue the remaining rules and application in next video. Thank you for watching.